Okay. So first one. So we did up to this level, this point, right? Last week. Yeah. So what is the source of nitrogen oxide and what effect do they have on the pH of rainwater? Answer. Yeah. Hurry up.
Comes from internal combustion engines.
Huh?
Internal combustion engines.
Internal combustion.
Engines.
Okay. So. Okay. So your answer is like engines. Okay. So what will happen to the pH value?
Lowest.
Huh?
Lowest.
Sorry?
Lowest.
Lowest. Okay. So, and then engines, combustion of fossil fuels. Okay. Combustion of fossil fuels. You can say agricultural activities. Okay, and the rainwater is acidic, so pH value is low. Find the concentration of the standard solution from this much of sodium chloride dissolved in this much of volumetric flask. How do you do that? Sodium chloride. So M of sodium chloride, NaCl. How much is that? 58.4 grams per mole. You have to write this, grams per mole. Then number of moles, number of NaCl moles, that would be 58.44 divided by 58.4, almost 1 mole. So concentration, what is concentration, right? Number of moles divided by volume. So that should be 1 divided by 0.5, which is going to be 2 m. Okay, done. Find the mass of anhydrous potassium carbonate needed to prepare 500 ml of this M standard. Okay. Find the mass of potassium carbonate. Needed to prepare 500 ml of standard solution. So, how much is the number of moles you have now? Number of potassium carbonate, K2CO3, is going to be number of moles, how much? 0.250 multiplied with? Huh? It's half, right? 0.5 in liters, na? That would be 0.125 moles. You have this much of moles now. How much is the molar mass? So this language is important. How much is the molar mass now? Say it again? 138.2 grams per mole, yeah? Right. Then how much mass do you need now? How much mass you need? So it's going to be N times capital M, right? Yeah? That should be 0.125 multiplied with 138.2, I think. How much is that? 17.28. That much of grams. Okay? Okay. This one? What is the volume of 0.2 m sulfuric acid that completely react with 8.9 ml of 0.3 m potassium hydride? Okay, so now we'll calculate number of potassium hydride, KOH. Potassium hydroxide. KOH is how much? 0.3 times. How much is the?
0.0.
Yeah, 0.0
0
0
8 9
8 9.
and that's 0.00
0.00
267.
267 moles, yeah?
Yeah.
Good. Okay. Then what?
You have to write the equation.
Yeah. You have to write the equation. So, how much?
H2SO4
Yeah, let me do that here. Yeah.
plus 2KOH.
Mm-hmm.
And that's 2H2O. And then K2SO4.
Right. So you get this much of things, okay. So sulfuric? Yeah. So you need half of the amount, right? 1 to 2, yeah? So you need half. So N of H2SO4 is going to be half of this guy. So 0.5 times 0.00267 number of moles.
And that's 0.0
0.001 3
3. Wait, I got 0.01335.
5 like that?
No, 1335.
1 what?
So there's only 1 0.
Like this?
Yeah.
Like this?
1 0. Oh, no,
It should be 2 zeros, yeah? Okay, so now the volume, right? So volume of H2SO4, yeah? That would be? That would be 0.001335 divided by
0.200.
0.200.
00.
You don't have to.
Wait, but do you have to?
No.
You have to have
No. So answer is 0. What?
0.0667.
Yeah.
7. This is in liters, huh?
Yeah.
So it's going to be 6.67.
Yeah, it's random. Wait, so you know like significant figures, yeah? My teacher was teaching it in class on how to find like which one to use, yeah? But I wasn't paying attention. Could you quickly like teach me some?
We'll do that when we get a proper question.
Yeah.
So we are not paying attention to significant figures here. Okay, fifth question. Okay, so question number 5. Okay, this is a proper question. 40 ml of 2M lithium hydroxide solution is added to 60 ml of 1M HNO3 solution which react according to the reaction of the given. Find the limiting reagent. How to do that? So moles of lithium hydroxide, how much is that?
0.008.
Okay, let me slowly do that. Lithium hydroxide, moles of lithium hydroxide is how much? 2 times 0.04, yeah? That should be 0.08. Okay, fine, Max? Now let's go to HNO3. N of HNO3, how much? That is, if I can see right, 1 times 0.06, yeah? So it's going to be 0.06 moles, right? So now you can see 1-to-1 ratio. So limiting would be what? HNO3.
Then what was your final answer? Oh wait, we got the final one right there. I got 4.
Yeah, so I was just messing with you.
All of you are okay with that? Cool. Okay, so what is the mass of lithium nitrate? Okay, so what is the mass of lithium nitrate in the reaction mixture after the reaction is complete? What is the mass of lithium nitrate? What is the mass of lithium nitrate? So it's going to be, tell me the number of moles of lithium nitrate now? 0.06, nah? Okay, so now you need mass. So tell me the molar mass of lithium nitrate.
68.
How much?
68.946.
68 point? 68.9.
46.
Okay, moles per. This is a molar mass, right? So, grams per mole. Okay, so the mass is
If we go beyond that, we'll be ready.
0.06 times 68.9. How much is that?
4.13.
4 point?
13 grams.
Good.
For the titration, my teacher said that you find the closest 3 meters and then just divide it to find the average. Are you meant to do that?
Yes.
Which one was that?
For the titration?
Yeah.
Close is 3 numbers.
Oh, okay. I don't get it. So you can make that
Wait, how are you?
Yeah, typically we take 3.
So we're still put acids in
right.
base.
Chapter 16.
Acid. Guys, we just let them put acid.
Before we do the
But my teacher's like slow and thorough.
Multiple choice test.
My teacher just be learning information.
what calibration was that?
Not for Spanish, I'm just asking.
It was like,
We'll go through that.
yeah.
We'll go through that. Okay, so the following titer were obtained when the solution of acid was titrated against a standard solution of base. Okay, titrated against the standard solution of base. Okay, so calculate the average volume of the acid that would be used to this calculation. How much is that?
25.
That's easy, right? 25? 25?
No, it's wrong.
632.
Huh?
0.632.
Wait, that's wrong.
That's when you add
He
over.
did the same mistake.
So, okay, so when you have this, you get the closest 3 values.
Yeah, which is 25.46.
Yeah, so what is the closest 3 values now?
2, 3, and 5.
2,
2, 3, and 5.
2, 3 and 5.
I would not do that.
Yeah. Right, so what is the answer?
25.42.
Okay, so it's going to be 25.46 plus 25.38 plus 25.42 divided by 3. 25.42. So you reject this because they are off. Question number 7.
Did you get this?
Hold on, Did you do all?
Okay, so you have to calculate the average of concordant titer, right?
I did it. Cool.
So what is the average of the concordant titer?
You take 3 except for 15.5.
Huh?
I need to do it.
Average of the concordant. How much is that? That would be 25.
Did you do this?
Okay, tell me the answer. 20, 47.05,
0.9.
right?
Yeah, 0.9 41.
Okay.
5, 6.
So now,
You're wrong, bro. I've made a mistake because I used to conclude it.
the concentration of hydrochloric acid is determined by titrating with the standard sodium hydroxide. Okay.
Got to run the equation.
So mole of sodium hydroxide, how much is that?
0.0478.
How do you do that? So it's going to be 1 times. 1 times you get 47.05 and then 1 is for 1000, right?
Oh yeah.
It's going to be 0.04705, yeah?
Yes.
Moles. So that is M. So now, how much is the mole of HCl then? Oh, whatever, N. Mole of HCl is going to be the same, 1:1 ratio, right? Yes or nobody?
Yeah.
Yeah. So now concentration. So concentration, HCl concentration is going to be 0.04705 divide by how much is the volume? 50, yeah?
Yeah.
Is that 50?
Yeah.
Wait, give me that.
So that would be
0.941.
How come this is giving me a different answer? Wait, so put it. Oh, I got the
Right.
right answer.
No, you didn't.
No, here.
Oh, you did.
I don't know, I changed it.
No, I didn't use the concording. It's too awful.
Are we all in the same page now? Yeah. You understand, right? The good ones I will give you. Good ones I uploaded in your classroom. If you check. Water. Yeah, these are still like baby diet, but important. Question number 8. A certain sample contains hydrochloric acid. Of the sample is diluted to this much in a volumetric flask.
Yeah.
25 ml aliquot of 0.5 m sodium carbonate solution was placed in a conical flask. If the indicator used is methyl orange and the solution was titrated with the sample, when the volume of the sample added to 18 point something milliliters, the indicator changed the color from yellow to pink. Find the concentration of HCl in the sample. Who did that? Neil, what is the answer?
I got 13.5.
Is that right?
Yeah.
Right.
Throw water at them.
Huh?
Oh, no.
Okay, I'll do that.
You write the equation first. So
Yeah. What is the equation?
Na2CO3 plus Na2CO3
Hold on. Hydrochloric acid is sodium carbonate.
and then 2 HCl and then H2O plus CO2 plus 2 NaCl.
H2O plus.
CO2
Mm-hmm.
plus 2 NaCl
Mm-hmm.
and that's it.
Okay, so it's 1 to 2 ratio, right? Okay. We'll try to understand number of Na2CO3 moles. How much is that? 0.5 divided by 1000. How much is aliquot? 25. Isn't it?
Wait, what?
Yeah.
Oh yeah, that's good.
0.0125 moles. Is that right?
Yeah.
Okay, so moles of HCl now?
Times 2, yeah.
How much is that?
0.
0.025. Is that right?
Yes.
Right. So now we need to find the concentration of HCl. Yeah?
Yeah, you can do it before the dilution, yeah, and then
Yeah.
multiply, yeah.
Yeah. So now concentration of HCl. Conc of HCl. That should be 0.025 divided by how much is the amount? 0. 0 point what? 018 something?
Yeah.
18 what? 4?
5.
5. How much is the number now?
1.349.
1.34
Uh,
9 m, right?
wait, 1.3549.
Say how much is that?
1.355. Yeah, this is random.
Okay. So now how much is the concentration of the original sample now?
The original. Yeah. 10.
Conc of the original. You understand what I'm doing here, buddy? This is before dilution, right? So it should be 1.355. That is inside 25, yeah? Yeah? But originally we had 250, yeah? Got it? So what theory we are using here?
Theory.
C1, V1, C2, V2, yeah? So basically, I'm a math guy, so I quickly put it there. So what is the answer? 13 point? That math intellect is important, right? So just to play with it. Small stuff. Boring. Tell me the answer. This is the easy version. Tell me the answer.
0.086.
0.086. Is that the answer? Yeah. So I'm not going to do it, but answer is 0.086. It's very similar to what we did before, right? Okay. This is the same question, right? Same question repeated. That's it. Given below is calibration curve of 5 standard solution of compound M. Right? Standard solution. What is a standard solution?
It's like a known substance with a known concentration.
Exactly. Known substance, known concentration. Right. So there are they. The content of M was analyzed by UV visible spectroscopy. Here the absorption of the solution at wavelength of 550 was measured as 0.17. Okay. Further, 0.125 gram of sample was dissolved in water and the solution was made up to 125. Okay. What is the concentration of M in 125 ml of the sample solution? Okay. So absorption is given to you. Absorption of the solution at a wavelength 550 was measured as 0.17. So 0.17 is, you take that to be is that right? That's not dot. Let's say this. Right? So that means the related concentration is 0.1 m. Okay. Oh, I think you asked me this question. There was a missing piece. The molar mass is not given, right? Yeah. Yeah, I remember you asked me this question. Let me check. Molar mass is not given in the question. Actually, molar mass is not given in this question. But you can find moles of M. But how that works?
Yeah.
So we can find
Because it's the same question.
moles of M, right?
Yep.
Moles of M we can find.
If you want to score high.
That would be 0.1. That's for 1000. Now you have 125. So if that happens, how much is that? 0.0125 number of moles, isn't it? So number of moles are there. So mass of M. Okay, so in this question, molar mass of M should be given. Let me predict that. Give me a second. Let me predict that. M. Yeah.
So you see the 0.125 grams?
One second, buddy. Say it again.
You see it says 0.125 grams of the sample is dissolved in water. Isn't that 0.125 the mass of the
0.125 is taken. So now I'm talking about molar mass.
The next question is
Does it do
asking
it?
for the percentage of the mass of M in the sample.
Please write once.
Huh?
How many hours? 1 2?
So you have to calculate like this. 0.125 x number like 100. This is what you will do. That's a percentage. You need to find this. What is the, yeah, in this part. Find the percentage by mass of M in the sample. So you have this much of the sample, right? You have this much of sample, but this is a sample, but M is here. M is this much. This is something else. So you need to find this is X. This whole thing is 125, 0.125. So you have to find X divided by 0.125. So this is the answer. So you need to find this X, the amount of M. So the details are not given, so that's why it's hard to do. Yeah.
So it says the sample was dissolved in water, right? So wouldn't that just mean the sample is just M and then you put it inside the water and then it becomes 125 milliliters?
No. Sample means the whole thing. Inside that you have M.
But then how do you put this sample inside water?
Why?
How do you,
You take this whole thing and then put it in water.
so then the outside circle is the water.
No. This is sample.
Okay.
This is M.
And you put the whole thing in water.
Whole thing into water. So I can't help much because it's the detail is not given to you. But this is how you do it. But so if 0.125 is the mass of M, then percentage is 100%. That's why it's,
The question is worded wrong. Right? Like,
yeah, so
it's meant to be
that's what I'm saying. MR of M is not given. So some details are not given, so don't worry. Don't worry about that. Give me another question which
125. Yeah, no.
this one.
Find this calibration to yeah. Yeah, actually, yeah, for the first time.
Oh, this has nothing to do.
Nothing.
It's just do this.
It's just plot the graph.
Plot the graph. Like your x-axis is concentration mg per liter, right? So your y-axis is absorbance.
It's just this.
Then if that's the case, you get something like this, right? So then the question is saying absorbance 0.135. Suppose 0.135 is here. Then find this value.
Yeah, it's like that. You should
Find this value, that's it. You have to plot it.
Should be dV.
You have to graph it. Use a calculator. I mean, this is a
Wait, sir,
note.
I have a question here. You know, like, I forgot where this is from, but like, you know how there's like RY and then like all the colors, yeah? And then for the absorbance, it's like different. You know what I'm talking about, sir?
Say it again.
You know when you shine a light, like colored light into a substance, yeah? And then the one absorbed, like, you know how there's like a... Wait, you know?
Okay, one absorb, the rest is emitted.
Yeah. Wait, how do you like predict that? Like, isn't there like, you know what I'm talking about? Like, Brian. You know how it's like, I'll find this one.
Absorption spectrum
Yeah.
or emission spectrum?
Excel sheet, yeah.
Wait, let me check.
Buddy, absorption spectrum means we measure what is absorbed.
Yeah,
Emission spectrum means we measure what is emitted.
yeah. But then, wait, it says, hold on.
Is it like, what is it?
There's like a formula here, like something you just memorize. Violet blue.
Yeah, what is it?
Where is this? Memorize this one, yeah.
Okay. Anything else? Okay.
Do you just memorize this?
Which one?
This one on 117.
Show me that. There.
No, you don't memorize it. It's just like, you just have to think about it.
Think
So
about
there's
it.
one on page 133.
Yeah, same thing.
Huh?
There's one question on page 133.
What question was that?
Like the calculation.
133. This one? Absorption concentration. In order to determine the concentration of iron 3 in the sample, the solution is diluted from 10 to 40 ml and the absorbance is measured at this. Find the concentration of this. So concentration 0.24. So 0.24 is somewhere here. Go here. Go there. This number. What is this number? X. So concentration is given. Suppose this concentration is grams per what? Grams per liter. Yeah. So usually this grams per liter or moles per liter, right? So the question is find the concentration of iron 3 ions in the original sample. Okay. So now 10 to 40. Yeah. So it's going to be C1V1 is equal to C2V2. So C2 is equal to that X value. V2 is going to be 40. V1 is going to be 10. C1 is what you need to find. So C1 is equal to 4X. X is this number, whatever the number here. So if that number is 0.15, 0.915. That's a question. Get it? Oh, you have to just predict here. So if it is middle, 0.15. In the actual question, you get the right point. So it's going to be 4 times 0.15. Yeah, so I just assume that number to be there. Okay.
You just take whatever.
Okay, we are moving to the last part.
Wait, so the 3-4 from the 1-2 cylinders, what's the main important thing?
Redox. I'm tired now. I'm going to take this example because I'm tired. In the student community, I see students, these are students. In the student community, I see these students. I see these students, right? Now, there is another student group, and there is another student group, like that. So, I'm going to put let's say a hat for these people. These are like, so educated kids, right? The people who have the neediness to study. For these people, I put a earring. Earring. They want to become tradies. I'm talking about boys, okay? I'm talking about boys. Right? Assume. It's a fair judgment. The reason is, when you go to medical school, you can't see medical school students with earrings. When I go to Chisholm, I can see 90% of them have earrings. So it's a fair judgment.
Wait, sir, in India though, yeah, like everyone wears earrings.
Huh? But Indian people come to Australia, they don't do that.
Wait, why?
Huh? You tell me
I
that.
used to wear earrings. No.
You tell me that, I don't know. Oh, yeah. No. I'm not talking about that earring. So they are putting earrings like gold.
Yeah.
Gold, right?
Yeah.
I'm not talking about that. I'm talking about that fake diamond earrings.
Oh, that's what I used to wear.
Yeah. Okay, listen. Hello. Now, these are 4 groups, right? These two are going to join this here. Do you think it is possible? Do you think that is allowed? Yeah, it is allowed. There is a natural matching, right? These two are going to join here,
Why is it his earring?
right? There is no natural matching. Why? Because they are different. Why are you laughing? These two are going to come here. There is a natural matching. These people are trying to go here. There is no natural matching. Agree with me? Natural matching. There is no natural matching, right? So, you understood the lesson now. So, now when it comes to molecules, we have 2 types of molecules. Polar molecule, non-polar molecule. Polar matching. Non-polar matching. Polar, non-polar not matching like this. Right? So that means they are not dissolving. Right? And that's the whole point of this lesson. So, yeah? Yeah. Okay. But why you are vibrating this?
I wasn't here.
My whole pen is vibrating. Alright.
What are you doing with it?
Okay. So, now look at this, guys. What I was saying, if this is polar molecule with another polar molecule, they miscible. That's what I was saying. Likewise, the other non-polar miscibility is there. Now think about this situation, okay? So there are 2 types of solutions. One is called stationary phase. Stationary phase. This stationary phase is a substance. So this can be polar or this can be non-polar. Then there is another substance called mobile phase. That's the name, mobile phase. This can be polar, that can be non-polar. You understand? Right. Now I'm going to finish the full logical part here through this. Listen to me carefully. So you have this is a cylinder, for example. This cylinder is called the stationary phase. What do you mean by stationary phase? When you do physics, there are things called stationary waves in VC syllabus. Stationary means stop. Station, railway station, stop. So they never move. So stationary phase is this. Then you can have the moving phase, which is called the mobile phase. This phase is moving, keep moving. Like water is going through a circular conduit, right? So this is mobile phase. Now what we do, we are going to inject unknown substance. We are going to inject the unknown substance. There are 3 molecules, for example, right? Now you tell me, now listen to me, if this unknown substance is going very fast, what is your conclusion? If this one is going very fast, that means this guy, these 3 guys, and this mobile phase has the same polarity. Like non-polar, non-polar. Get it? If this guy is going fast and if this guy is going slow, that means that this one has the opposite polarity. That means this is polar, maybe the mobile phase is non-polar, right? So that's the whole business here, right? Now how do you understand this? You are going to have a camera here. So this camera will detect which one comes first, which one comes later, and which one is moderate. Camera will detect. So based on that, you will get to know the substance, with the polarity of the substance and the substance. Right? This is a very primitive type of experiment to understand the substances. Right? So this is called chromatography. Right? And there is another word we use here, adsorption, not absorption, adsorption. Adsorption is nothing but, you can think, absorption. Absorption is solvent is penetrating through a material, that is called adsorption. Right? Usual word is absorption. Right? So same thing. Yeah, that's all about the theory. See, stationary phase I am explaining here, mobile phase I am explaining here. Yeah, and then yeah. So any issue with this? No.
Question. Is it just experimentally the non-polar one? If they're both the same, it goes really fast, and then is it experimentally, or is there like any reason?
What do you mean by reasoning? They are miscible.
So
non-polar miscible.
Yeah, they're miscible. So shouldn't it like dissolve in the same place?
No. It's just like this. Suppose this is non-polar, right?
Yeah.
Suppose this is polar. So
Yeah.
if it is non-polar, the stationary phase is polar. This mobile phase is non-polar. Suppose this guy is polar. Then what will happen? This guy is more attracted to the surface. Because of that, the motion is slow.
Yeah.
That's why.
Wait, so I'm not confused here, sir.
Yeah.
So is there like a substance inside of the cylinder, like a liquid, yeah?
Yeah.
And then that one,
Okay, that liquid is called mobile phase.
yeah,
Yeah. That mobile phase should be polar or non-polar.
yeah.
Yeah.
And so what's the, the blue thing on top of the mobile phase, yeah?
Yeah, that's a stationary phase.
And that's going to be a different, so the,
That's going to be a different material.
yeah,
That's a different material.
yeah. And so that's going to be a solid, yeah?
Yeah.
And so, the thing we're injecting, right?
Yeah.
So, will that be attracted to the solid?
This can be a solid or that can be a jelly type of a material.
Yeah. So if the solid is polar, right?
If this is polar, you can consider this to be polar.
And then
If this is polar, if this is polar,
yeah,
and then mobile is going to be non-polar,
yeah,
so then this polar substance is more attracted to the stationary phase.
so it'll be going forward, right?
Going forward,
Yeah,
but attracted to the
yeah,
stationary phase. So because of this attraction, this is going slowly.
yeah,
It's like this. You understand what I'm saying?
yeah, I understand.
Yeah. Yeah. So it's like this. So this is a river, right? This is a river. River is the mobile phase, right? So I'm the substance, right? So all these girls are stationary, right? So there is a girl which I like, yeah?
Yeah.
What I'm doing? I'm going, but I'm slowly. You understand? You understand? But I'm going slowly.
Wait, so what is that attraction called?
Huh?
What is that attraction called? No, like
What is that attraction called?
yeah,
So it's an electrostatic attraction.
yeah,
Because polar, non-polar. Polar is because of the electronegativity, right?
yeah.
So
yeah.
yeah,
That makes sense.
charges, right?
Yeah. Wait, so a solid substance can have a charge?
Yeah, why not?
Okay, yeah.
So then how come the current goes through wire?
Yeah. Wait, no, but the current goes through the wire because of delocalized electrons, right?
Doesn't matter.
Okay, yeah.
Doesn't matter.
That thing that you inject, right?
Huh?
The unknown substance.
Have you seen? Hello. Have you seen if you have a paper, like can be a, I don't know what papers are they? We had it like when I was a kid. I had it's like an A4 type of a paper, says strip. You cut into pieces and then you put into water. So slowly you can see the water is absorbing. Like water is moving up, right? Actually, why they are moving up? Because that's a physics concept, because of the surface tension, right? But that doesn't really matter. So the water is coming up through the strip, right? That is what is happening. So now, yeah. So even I have done that experiment as a kid. Like you put like some color in it, like blue color, and you put the strip, and you can see the blue color is coming. Blue color is coming, and then water is coming more than that. Means, like I have seen, like this is the beaker, this is blue, right? So when I put the strip, I can see the water level is here because water is rising, yeah, and blue color stopped here. So this all blue. I can see this part. I can see this part is wet. That means water has gone up. The blue column is the blue particles, right? Blue particles stop rising at this point. So that's how you sort of differentiate that blue particle. Yeah. So that's due to this absorption. Absorption, but we call it adsorption. So that's what it says.
Wait, so can you show us a video of like the actual thing?
Okay, I'll find it.
Okay, yeah.
I'll find it. Okay, go to your portal.